Hello everyone. So today I'm going to discuss the topic which is steam steam turbine. Steam turbine is a prime mover which convert heat energy of a steam into mechanical work, which is utilized for electricity generation. The steam turbine used nowadays, which are axial flow machines, that is steam flow over the blade in a direction parallel to the axis of rotation. So first of all, we can classify the steam turbine. So classification, we'll talk about the classification. So the first basis will be based upon working principle. Okay, so based upon working principle, there can be two types of turbines. The first one is impulse, and the second one is reaction. Okay, so impulse turbine. If I talk about impulse turbine, so there are two steps involved in the impulse turbine. Let's separate this. So if I talk about impulse turbine, so there will be a set of nozzle and moving blade. Now we'll see the variation of different parameters. Okay, this is the impulse turbine. So if I talk about the pressure variation, pressure variation, then in the nozzle, so nozzle is fixed. When the steam passes through the nozzle, velocity increases and its pressure uh, continuously decreases. And in the moving blade, because it is impulse turbine, so there is no pressure variation. So the pressure will remain constant in the moving blade. Okay, so we can say that here pressure is P0, this is P1, and here P2, which is equal to P1. Okay, and if I talk about velocity, so velocity, because in the nozzle velocity increases continuously, so graph will be something like this. And in the moving blade, because it is moving, it is transferring its kinetic energy to the blades. So velocity get decrease. So we can denote like this: V0, V1, and V2. And what about the relative velocity? So when the steam comes out from the nozzle, so its relative velocity gets decreased because relative velocity will be Vr is equal to V1 minus U, where U is the blade velocity. Blade velocity. Okay. So its relative velocity will be this Vr1, and across the moving blade, because it is impulse turbine, there is no pressure change, so its velocity, relative velocity remains constant throughout the moving blade, which is equal to Vr2 is equal to Vr1. Okay. And if I talk about the reaction turbine, and if I draw the uh, different sections, like we'll have here first fixed blade and then moving blade. Now we'll see the different variations. Okay. like pressure and velocity, like an impulse turbine. Okay. So in the impulse turbine, if I see pressure and velocity variation, so the pressure, because in the fixed blade, it is not a nozzle, it is just fixed blade, but it is aerodynamic in shape. So it acts as a nozzle. So the pressure decreases continuously, and the moving blade pressure again decreases. So from pressure P0, it comes to P1 and then P2. And if I talk about velocity, then in the fixed blade, because it is working like a nozzle, velocity increases, and in the moving blade, velocity decreases. V0, V1, and V2. Okay, this is the variation. Now let's see about the orientation and the shape of the blades. So in the impulse and reaction. Okay, in impulse, the blades are something like this, just simple geometry. It means that steam comes here, goes out, and the section remains constant. Okay, and in the reaction turbine, uh, if I draw something like this, like this is the fixed blade portion, this is the moving blade portion. Okay, so in the fixed blade, because the blade is in aerodynamic shape, it will be something like this and this, and here it will be like this and this. Okay, so steam comes here and goes out from this direction. Okay, so we can see that it is aerofoil type unsymmetrical blade. Aerofoil type unsymmetrical blade. Okay, so this is the blade orientation. So here the space is not constant; it is different, which is not. So if I'll distinguish the blades of impulse and reaction turbine. So in the impulse turbine, it is called profile type. Profile type symmetrical blades, and this is aerofoil type. Okay, let's calculate the power output from the turbine. In case of turbine, what is power? So power can be given as VW1 in minus VW2 into U. I will derive this formula in some other lecture, and it can be drawn as V1 square minus VT square by 2 minus VR2 square minus VR1 square by 2. One thing I forgot to mention here, that in case of reaction turbine, what about the relative velocity? Because from the fixed bed, when velocity becomes v1, and because the blade is moving, so Vr is equal to v1 minus u, velocity gets reduced like Vr1, and because it is moving blade and it is aerodynamic in shape, so its relative velocity increases, because that moving blade act like a nozzle, so its relative velocity increases Vr2. So its outward relative velocity is more than the inward relative velocity. That's why it is coming here VR2 square minus VR1 square. So here this term is called the impulse term. The impulse term, and this is called reaction term. Okay. So if I talk about the differences between the impulse turbine and reaction turbine, so the first difference is that in case of impulse turbine, pressure drop takes place only in nozzle, and there is no drop of pressure across the moving blade. But in case of reaction turbine, pressure drop takes place both in fixed and moving blade, like this. Okay. In case of impulse turbine, blade cross-sectional passage is kept constant across the moving blade, like this. We can see here. The velocity passage is constant along the moving blade. And in case of the impulse turbine, blade cross-sectional passage is made converging type, both for fixed and moving blade. Like here we can see that the passage is converging in case of fixed as well as moving blades. Okay. And in case of impulse turbine, profile type symmetrical blades are used, and in reaction aerofoil type unsymmetrical blades are used. In case of impulse turbine, blade design and manufacturing is simple, so the impulse stages are cheaper. Okay, and in case of reaction turbine, blade design and manufacturing is difficult and complicated, so the reaction stages are costly. In case of impulse turbine, power developed and efficiency is less. Power and efficiency is less in case of impulse. But in case of reaction turbine, power and efficiency is more. Because here we are also utilizing the pressure, which we are not able to utilize in case of impulse turbine. And in case of impulse turbine, partial emission of the steam through the nozzle takes place. And in case of reaction, all round emission of the steam through the fixed blade occurs. Okay. In case of impulse, preferred for the small power need with low investment, and for the case of Ericsson turbine, preferred and large power need with the heavy investment. So this is the basic fundamental of the steam turbine and the differences between the impulse turbine and Ericsson turbine, and these are the classification based on the working principle. Now we'll classify based on other parameters. Thank you.